Hey guys, today we are going to be solving this AP Physics FRQ. This is a Unit 2 FRQ. And it says, a rope of negligible mass passes over a pulley of negligible mass attached to the ceiling as shown above. So, ignoring the mass, the rope is attached to this, right? Okay. One end of the rope is held by student A of mass 70 kilograms and student B, who is suspended at rest above the floor. So they're at rest, but they're in the air, right? They're 60 kilograms. So on the dots below that represent the students, draw and label free body diagrams. So to start with, we'll start with student A. When we look at student A, we know that there's a force of gravity always acting, right? So here's my force of gravity, right? And then when I look at all the forces upwards, I know I have tension, right? So I'm gonna label tension, which is right here. And I also have another force, the force in which the floor is pushing right back up, the support force, the normal force, whatever you want to call it, which is my normal force. And then that's it. You're done. These are the forces. You're done, and you won't break them up to its components on a free body diagram, so you would have to do it separately. Okay. Now, for student B, we have the force of gravity once again acting on student B. Here is the force of gravity. I'm going to actually label them like this. It's for FG is equal to mg, but just because we're going to have to compute with them. So MA of G. Okay. And then we have, once again, tension acting on the student. Okay. That's it. That's your forces labeled. B says, calculate the magnitude of the force exerted on the floor by student A. So you're calculating the F net of student A, right? In its essence. So the sum by student A. So the sum of the forces for student A is what you're basically solving for. So let's take what we put our free body diagram as, which is right here. Let's just do it really quick like this. Okay, MA of G, tension, and the normal force. Should be a little higher, but you get it. Okay, so when I look at these forces, I can say that the normal force plus tension minus this force of gravity should equal to 0, right? Because we're not moving, standing straight. So the normal force plus the force of tension minus the force of gravity for student A is equal to 0. This is the sum. This would get you 1 point right here. Next, you have to calculate it now. So I would rearrange this equation. I would add this over here to give me N force normal plus the force of tension equal to MA of G. This is the first part, right? Okay. Next, you have to find the sum of the forces B in order to plug in and solve for the magnitude of the force exerted by the floor on student A. What this means is that you're solving for your force normal. The magnitude of the force exerted by the floor. The floor is doing this work right here. This is your force normal. Here's my force normal. But when I solve for force normal right here, I see that NA is equal to MA of G minus force tension, right? But we need to find force tension in order to solve. So in order to solve for force tension, we're going to have to look at our little vectors for B. Here's my vectors for B, tension and mass B of G, okay? And I'm going to calculate the sum of the force B's, which is going to be equal to, obviously, the force of tension. Actually, let me put force of tension B minus force of gravity, right? So MB of G, and that should equal 0, which also means that the force of tension for B is equal to mB of G. So now, when I'm solving for the force normal, I'm calculating it, I have this formula to use, which is I'm going to plug in my force tension right here, right? And I'm going to erase this. And I'm going to get my formula to be the normal force equal to mass of A, G, right, minus the mB of G. We just established that, right? Force tension is going to be equal to mB of G. And I'm going to solve like that. So my N, my normal force, is equal to 9.8. And the reason I'm going to tell you actually factor it out. So here's your G, mass A of mB, or you could do mB minus, it doesn't matter. This. So N is equal to 9.8 times 60 minus 70. And I'm saying minus 70 because this is negative times a negative. So I just switched them. And you're subtracting. Same thing. Whatever. And this is going to give me a force. I'm going to cancel out all my negatives and get a force normal of 98 newtons. And this is the answer. Now, part B says, student B now climbs, sorry, not part B, part C, that's what threw me off. Student B now climbs up the rope at a constant acceleration of 25 meters per second with respect to the floor. Calculate the tension in the rope while student B is accelerating. Well, we just said that the force of tension is going to be equal to mB of G plus mB of A. And how we know this is when we sum our forces for force B, which is right here, tension minus this is going to give me my mass times acceleration. And here's my mB of A. And this is because they're telling me there's acceleration, which means you're in Newton's second law, which says that F net equals ma. And this part is your F net. Okay. So, in order to solve for force tension, you can say that force tension is equal, sorry, my pen is not working. Force tension is equal to mBg plus mBa. You solve. Force tension is equal to 60 because I'm going to factor out the masses, right? So mass times mass of B, G plus A, doesn't matter, 60. And then I'm going to 9.8 for my gravitational constant plus 0.25, which is the given acceleration right here. And I'm going to solve, and you will get a value of 603 newtons. This is your force tension. Okay. D. This is more of a concept question because if you know if you understand what they're asking here, you can easily solve for this. Okay. So, as student B is accelerating, is student A pulled upward off the floor? Justify your answer. So, as student B is accelerating, right, is student A going to be pulled up? The answer to this question is no. No. Okay. This is because there's a minimum tension required to lift the student A. The minimum tension required is the weight of student A. The weight of student A is also equal to mg, which is the 70 kilograms that the student weighs times 9.8 meters per second, which will give you a value of 686 newtons. And as we found force tension to be 603, force tension is less than 686 newtons. Therefore, student A will not pulled up. Will not be pulled up. Okay, E says, with what minimum acceleration must student B climb up the rope to lift student A upward off the floor? You're solving for acceleration. Okay, so we have to think of the sum of our forces because they're asking you what minimum acceleration for student B to pull student A up. So the sum of our forces for B, we found again to be force tension minus mB of G. And we're going to put it equal to mB of A because F net in the second law, F net is equal to ma, and they're telling you there's acceleration. They're telling you to solve first. Of course there's going to be acceleration, right? So we have to rearrange this to solve for this little princess. So, force tension minus mb of g, or force gravity for b, divided by, we're going to divide out this, mb is equal to our acceleration. That's it. Now, solving for acceleration is simply plugging in everything you found. Force tension, and you have to use force tension for A, right? Because to lift student A, you're solving in regards to student A, so you need to use this 686 newtons you just found. So 686 newtons minus the mass of B, which is 60, given to you, times 9.8, divided by 60, which is again the mass, which will give you a value of 1.63 meters per second squared. And this is your final answer, and this FRQ is done.